We've gone live. Okay, ladies and gentlemen, are we live now? I've been presenting for about 10 minutes and then a flood of reports came in saying, hey, nothing's happening here. YouTube is goofing around. So I'm going to wait for confirmation from a couple of people here in the chat, or I've got people dinging me on text and on Skype. As soon as I get confirmation from someone that we're in, oh, okay, we've got one person saying we're in. Great. All right, can I get a second? Okay, good. Thank you, Scott. We're set to go. Okay, ladies and gents, let's go ahead and we're going to start over. So, on the computer screen here, all right, Jupiter and Saturn, this is the Great Conjunction of 2020. Some people are calling it the Great Conjunction, some are calling it a Grand Conjunction. Just depends on which headline you're looking at. Jupiter and Saturn are the closest that they've been to each other in the sky since 1623. Now, this does not mean that they are necessarily close to each other in space. Here is a look at the solar system from a screenshot of Sky Safari, and you can see that this was taken earlier today. We've got the sun in the center. Here's Earth. Jupiter and Saturn are still in their normal orbits. They're not particularly close to each other. We're still talking hundreds of millions of kilometers away from each other. But because of the angle at which we are looking, Jupiter and Saturn fall almost exactly on a straight line, and so they appear extremely close to each other in the sky. Tonight, actually just a little bit ago, they reached about 1/10 of a degree apart. For reference, when you look up at the full moon at night, that is roughly half a degree wide. So we're talking about 1/5 of the diameter of the moon. Now, we have Jupiter and Saturn in the view here. Let's go ahead and we're going to reset things here a little bit. Jupiter is very low in the western sky for me here in the Mountain Time Zone right now. Those of you guys out east, Jupiter is probably already down below the horizon. So what we're looking at is we're never going to get a super crisp view with the planets so low, but we're going to do the best that we can. Now, here we have Jupiter and Saturn. You can see Jupiter on the left. Many of you might not see Saturn, but this little smudge right here is the ringed planet. And the reason that they don't look so impressive necessarily here on the screen is because your eye is infinitely better than any of the cameras that we can use. Well, maybe not infinitely, but significantly better. And that comes down to what we call dynamic range. Basically, your eye has the ability to take really bright things and really dim things and still be able to look at them both at the same time and see all of that detail. It can handle just an incredibly wide range of brightnesses. Cameras are getting better, but they still aren't there. And what happens is, for faint objects, we need to turn up the brightness, and in the process, so let's go ahead and we're going to turn up our brightness. Take a look at Saturn here on the right. We're going to turn up our brightness, and there are two ways to do that. One is by taking a longer exposure. One is by changing the gain. For those of you who are familiar with photography, especially old school photography and film cameras, gain is basically like your old ISO. It's how sensitive your film is. So if we turn that up, like right now, this would be, suppose this is an ISO 400. If we turn the gain up, now it's an ISO 800 or something. But we can turn the sensitivity up, and there we finally have Saturn bright enough for us to see a little bit of detail. We can see the ring. We can see the gap between the ring and the planet. But we had to turn the brightness up so much that now Jupiter is just all blown out in terms of brightness. The human eye could handle the differences between these two, but the camera really, really struggles. Even more of a struggle is seeing the moons of the planets. I was looking at Sky Safari, well, really for the last couple of weeks, kind of doing a preview of this, and believe it or not, the view here is full of all kinds of moons of Jupiter and Saturn, but they are so much dimmer than the planets that we're having a hard time seeing them as well. But we're going to go ahead and we're going to turn the brightness up, and we're going to try and catch some of these moons out here. So I've turned the gain up about as much as I want to. This time I'm just going to turn up the exposure. Bum, bum, bum. Okay, around Jupiter, see we have 3 of its moons. 1, 2, 3. Actually, there are 4 moons, Galilean moons of Jupiter orbiting it. Io, I eat green carrots. Io, Europa, Ganymede, and Callisto. I'm not 100% which one is which based on just the screenshot here, but I can find out in a moment. However, what I can tell you is that the reason we're only seeing 3 of the moons is because Ganymede, the 3rd moon out from Jupiter, is actually in front of the planet right now. It is transiting the planet, and I'm looking at Sky Safari. Let's take the brightness back down a little bit. Okay, if we were looking at just the planet, so we had 1 moon up here, 2 moons down here, Ganymede is in front of the planet right about there, right around the tip of the cursor. However, again, just because it is so dim compared to all the brighter objects, the planets here, it's going to be extremely difficult for us to spot that moon as it passes in front. Had we been able to get out here about an hour ago and catch Jupiter and Saturn here, we would have seen Ganymede right on the edge, and we would have seen it disappear as it was sort of swallowed up by Jupiter, and its view is erased by the brightness of the planet. There are a bunch of moons of Saturn as well. Let's see if we can spot a couple of them. Okay, there we go. Well, actually, before we move on to Saturn, let's go ahead and we're going to take a look at which moon is which here. So around Jupiter, we have the planet there. We've talked about Ganymede being right there in front. Europa is on the upper side here. This is the 2nd moon out from the planet. Europa is a fascinating world. There is a subsurface ocean of ice that we've never been able to penetrate down to because the moon itself is encrusted by a solid shell of ice. And the depth of the ice is a little bit up for debate, but it's roughly 10 to 15 miles thick. There is a mission that NASA has on the books for trying to go and visit Europa, because with liquid water far, far down there below the ice crust, we are thinking that this is probably one of the 2 or 3 best places for a shot at detecting other life in our solar system. The moon just below here, the first one down here below Jupiter, that is Io. Io is the closest moon, and Io is a fascinating creature in its own right. It is the most volcanically active object in our solar system. Because of the massive gravitational pull from Jupiter, but then also the moons just outside of Io, they give gravitational tugs on it. This basically stretches the moon every couple of days. And the result of that stretching is fairly significant. Just like we have tides in the water here on Earth because of the gravitational pull of the moon and also the sun, the tides here on Earth can be a couple feet high in most places. There are a few spots on the globe where tides can be truly extreme, like the Bay of Fundy, where the tides are something crazy. What are they, over 100 feet? Well, on Io, there is no liquid water. There is no liquid magma. It's still cold enough that everything solidifies basically right away once it spews out onto the surface. But the tides on Io are in the rock. The land itself stretches, and it can be up to 100 feet high. So the ground itself swells 100 feet during certain times, depending on how the outer moons team up to give the moon a bit of an extra gravitational tug. Way out here on the edge, we have Callisto, the outermost of Jupiter's 4 Galilean moons. It's very icy, it's very cratered. There's not a whole lot of excitement there. The other moons have much more going for them. I'm going to try and stretch this image just a little bit more. We're going to get Saturn centered. I'm going to turn the brightness way, way up, and we're going to see if perhaps we can catch a couple of Saturn's moons around the planet. With your eye looking through the telescope, you can definitely see the moons of Saturn. But then again, we are right back to what I was talking about earlier. The human eye is just so much better, so much more well equipped to handle the different brightnesses. All right, we're getting a few moons here. They're faint. See this guy just off to the right? Let's take a look at Sky Safari, my most trusty astronomy app. All right, we've got Europa. Ooh, that is not what I thought it was. So the largest moon... how's this flipping the view? The largest moon around Saturn is the moon Titan. Which, actually, yes, this would be Titan right here. Titan's a fascinating moon because it's the only moon in the solar system that has an actual thick atmosphere. There's a lot of methane, a lot of nitrogen in it. The atmosphere is so thick that it's slightly opaque because of the composition, and we can't see down to the surface of the moon. The first time we saw the surface of the moon was when the Cassini mission sent a small lander, the Huygens probe, down to the surface, And that was really the first time we got to see it. And there was all kinds of fascinating things. It's a heck of a lot of cold out at this region of the solar system. It is so cold that we're talking about liquid methane lakes. And there is a form of water cycle, only it's not water. It's methane. Oops, turn off my phone here. And there are large bodies of water, or large bodies of fluid, I should say, with these various liquids. Now, out here between Jupiter and Saturn, let's see, we have this little guy right here, might be Enceladus. Which is another moon in the solar system where we are almost absolutely sure that there is liquid water. Because the Cassini mission, when it first arrived around Saturn, took some stunning images. And they saw geysers spewing water, which quickly froze into ice, obviously, out into space. And this is actually what forms one of the small and faint rings around the planet. Not one of the ones you'd pick up in a backyard telescope, but if you look at a professional observatory's image of Saturn, there are a number there that have the ability to get that kind of detail. All right, let's turn this back down a little bit. We're going to just focus on Jupiter. We're going to stick with Jupiter and Saturn here as long as we can. Again, they are getting lower and lower and lower in the night sky, which actually means that what I'm going to do just very briefly here, ladies and gents, is I'm going to snap a quick image. And what I'll do is I'll process this later tonight, and I'll share this out on my my Instagram account at AstroZach. So please follow me there if you want to see some of the follow-up images from this, and also some other astrophotography that I've been working on here of late. And you might think, oh, he's not going to be able to see anything in this. Well, in image processing, you can kind of stretch the brightnesses, and so we'll be able to see a little bit of Jupiter and Saturn. Now, looks like we might be... Oh, we're really picking up some turbulence now. The ideal time to view the planets is when they're highest up in the sky for the night. And that is, there's actually a term for that. The technical term for the planet at its highest point in the sky for a given day is called its transit time. It's like the planet's version of noon. However, here, let's go ahead and I'm gonna try and catch one more set of images while we watch here. Whoa, what are you doing? And that is what we want to see is we want to see the planet when it's at opposition. And opposition is like the full moon for a planet. And let's go ahead. We're going to take a look at opposition. So here, this is what we had back in July. And basically what opposition is it's when the planet is on the exact opposite side of the Earth. Here's Earth in this little blue-green spot right here. The planet is on the exact opposite side of the Earth from the sun. So it's like the full moon version of the planet. The planet will be 100% lit up. It's also, as you can see, the Earth is close by. This is generally about the closest time the two planets are going to be to each other in space. So usually within a few days, this is the closest that Jupiter and Earth will be for the year. And the same with Saturn out here. So Jupiter reached opposition on July 14th this past summer, and Saturn reached opposition literally only about a week later. I believe it was July 21st or maybe 22nd. Now, usually those two opposition dates are not that close to each other, but we're getting them that close to each other this year because the planets are working their way towards this great conjunction. I'm going to go back here real quick. Tonight's event is great because, whoa, what's it doing? There we go. Is great because we do get to see Jupiter and Saturn closer to each other than any time during the last 400 years, back to 1623. However, notice how the two planets out here, if you draw a line from the Earth to Jupiter and Saturn, the sun is not too far away from that line. This is also why the planets are low in the sky right now. What would be really exciting is to have a grand conjunction around the time when the planets are also at opposition with Earth. I was able to take some images this past summer. Oh, there we're really losing Jupiter. Let me look over my shoulder. Oh, Jupiter is behind a tree now. It's dropped down below the local horizon, so that's going to be it for Jupiter and Saturn for the night, I'm afraid. Oh, well, we can kind of stretch it out a little bit here, but we can't really see any detail. So let's give them a rest a little bit. Earlier this summer, I was able to get some imaging in on Jupiter. This was, I believe, on July 4th or 5th. And Jupiter was physically much larger in the sky, or apparently much larger in the sky, because, again, it's at that closer distance to us. And we're able to see all kinds of coloration and detail. We've got the great red spot. We have all of these color bands. And let's talk about color bands for a little bit. Saturn also has color bands, but they are much, much more subtle than on Jupiter. And right now is really not a great time to see that because Jupiter is not visible until the late evening when it's low in the sky. But what causes all these different color bands? Well, if we take a look at the atmosphere of Jupiter, there are different levels, and a lot of these are similar to levels that we have on Earth. You know, we have the troposphere, the stratosphere, and so forth. Well, Jupiter is layered by composition. So each layer, in addition to having a characteristic temperature, the composition will also change. So we've got some haze here that's kind of a mix of all kinds of things. We have the troposphere, and below that we get some ammonia ice, and then ammonium hydrosulfide ice, water ice, and then we get down to all kinds of mess down here. But you can see how there are different colors represented at different layers. And that is what we're seeing when we look at color bands on Jupiter. We're seeing essentially different depths. So let's see if I can pull both of the, oops, sorry Jupiter. We're going to try and get these two to share the screen. All right, there we go. That'll have to do. So the light-colored bands on the planet Jupiter are referred to as zones, and you can see that those are areas where we have warm material rising, and it's kind of like a cumulonimbus cloud here during the summer on Earth. We have these massive upwellings of moisture due to warm areas down below, and then the other side of the convection cell, after the material rises, because it's warm, it eventually cools, and when it cools, density says, I'm taking you down. And so the cool material will sink back down, and it'll churn up material, and that's where we're seeing some of these belts. So we have zones, and we have belts. And we're going to come back to that one. These are regular features on Jupiter, but they aren't 100% constant. They can vary a bit over time. We're going to do a little comparison here. Let's pull Jupiter right back up. All right, you can see my image is flipped a little bit here. Well, not a little bit, it's flipped entirely. And that's just because of the optics in the telescope. But there's the Great Red Spot. The Great Red Spot is part of the southern equatorial belt, which is right here. And we can see it in the corresponding real image. Well, this is actually a real image as well, but that's it's kind of cheating. That's NASA. This was taken either by Hubble or by the Galileo mission, because this is an image that's a number of years old now. And we've got other equatorial belts and zones. And like I said, these things are regular, but they're not entirely constant. Some of these bands and belts can disappear over time. So for example, about 10 years ago, the southern equatorial belt, which the Great Red Spot is just on the edge of, it just disappeared for a couple of months. And you can see it here, just was gone. Now, the Great Red Spot was still there. This May 9th, 2010 image that you're seeing, the Great Red Spot is simply on the far side of Jupiter, facing away from us, and so we aren't seeing it. But the band, as you can see, has reappeared. It was part of the view just this past summer. Now, let's go ahead and we're going to talk about the Great Red Spot just a little bit. I don't believe the Great Red Spot was really out and visible tonight. Let me zoom in on SkySafari and confirm that. Yeah, the Great Red Spot is on the far side of the planet. So even if we had perfect viewing conditions tonight and the planet was higher up in the sky, we wouldn't have seen it this evening. But the Great Red Spot is actually in the process of shrinking. For about 100 years, there's been a steady trend of it being smaller and smaller. I forget if it was earlier this year or if it was last year, 2019, when astronomers were looking at it, amateur and professional alike, and wondering if the Great Red Spot was about to just go ahead and dissolve completely, because it started shedding these long streamers, which are not in the image here, but they're large chunks of the outer band, the outer circle of the Great Red Spot here. They just seem to kind of peel off and become part of the southern equatorial belt. Now, Jupiter does this somewhat frequently, every couple of years, but it did it several times in this last occurrence, which is why people wondered, oh my goodness, are we about to see this thing go away? The Great Red Spot has been visible with the aid of a telescope since the telescope was invented way back in 1610. So to see this go away would truly be an amazing, amazing thing. It has made a little bit of a resurgence, or at least it's stabilized, and is no longer shrinking. And yep, our view of the planets has gone for the night. Now I want to talk about one more thing on Jupiter before we kind of move along to some other ideas. And see that dark spot? I'm not able to check on the different let's see, comments. Hey, if you guys have any questions, please throw them up in the comment section. As you can see, I've only got one screen here, so I'm not able to really get in and check your comments too frequently, but I'll try and check on those a little bit more often here. There we can. So what's this black dot all about? Well, like I was talking about earlier, and tonight we have Ganymede passing in front of the planet about an hour from now. Yes, about an hour from now. Just like Earth's moon casts a shadow into space, and occasionally we get to see that when that shadow touches the Earth, we've got a total solar eclipse. Well, other moons in the solar system can do the exact same thing, which is pretty stinking cool. So in about an hour, Ganymede, the moon, is already in front of Jupiter now, but its shadow will finally work its way onto the disk of the planet. And just like in this image from this past summer, the shadow of the moon will cast this perfect black spot onto the surface of the planet. I'll be doing, eventually, I'll be doing another live stream when Jupiter is a lot more favorably positioned, and we'll try and watch a couple of these through the telescope. And what can be really exciting is every now and then, a couple times a year, you can get two of Jupiter's moons casting their shadows on the planet at the same time. And once every couple of years, or maybe it's once about every decade, you can actually get a triple shadow transit, is what they call it. The shadow is transiting, moving across the face of the planet. And there was one earlier this year, I think, but it was not visible here in the Western Hemisphere. So I'm trying to remember, I think this was Io back this past summer. And Io actually will transit the planet a couple of times a day. Or no, once every other day, I'm sorry. Because Io has a very fast orbit around Jupiter. It only takes about 1.78 days for that little moon to whip all the way around that giant planet. So again, keep an eye out. I'll be doing some live streams of different things going on with the moons of Jupiter, whether that's the moon transiting or whether it's casting its shadow. Or what's also really cool, and I've never honestly seen myself, is when you get the moon working its way around and it enters the planet's shadow. And when that happens, here's another black and white look of the same picture I showed you a few moments ago. This was taken just a couple of days before the previous one. When you have a moon over here and it enters Jupiter's shadow, Jupiter's casting a shadow out into space just like Earth does, and the moon can actually just disappear in the middle of space. So you'll have a moon hanging out right here, and all of a sudden, bloop, it'll be gone. Now, it's actually not bloop. It does slowly fade out, but it's not too slow because the moon is not that large compared to the planet, and it's moving through its orbit at a pretty decent clip. So all kinds of fun stuff with Jupiter's moons. We've got transits, we have shadow transits, we have eclipses when it just disappears like I was talking about, and we have situations where, okay, if Jupiter's casting its shadow up and to the right here, what happens if a planet comes around from the lower left? It can actually pass behind the planet and be occulted by it. So 4 different types of events are possible with Jupiter's shadows and Jupiter's moons. To give you a little bit of an idea for what tonight looks like, here's a simulated view. And there we go. So this is tonight, and then tomorrow, starting now, the planets are already moving apart from each other in the sky. Now, some of you have, I believe, seen what I shared on Instagram earlier today. The planets have been moving apart from each other, or moving towards each other in the sky. Let me find where that is. And of course, it doesn't want to cooperate. Well, if you check out my Instagram feed at Astrozac, the video that I posted earlier today is a sequence of images that I've taken since December 8th. And basically, I go out and I take a quick snapshot of the planet at roughly the same time each night. And we can see the two planets growing closer and closer. With that, I'm actually going to take about a 2-minute break here because I'm a little bit overdue for taking tonight's image of that. It's set up about 30 yards off to my right. So you ladies and gents, hang on for a moment, and then I'll come back after the photo, and we're going to switch targets a little bit. We've lost Jupiter and Saturn, but we have not lost the red planet. So we'll go and we'll take a look at Mars here shortly. I'll be back again in just 1 or 2 minutes. Okay, snapshot is taken. I'm back. Let's go ahead and we're going to continue on. I'm going to check the live stream here. Did anyone have any questions? Real quick. If you've got questions, please, again, feel free to ask them in the live chat. I'll come through and answer those as soon as I can. We're going to switch back over to the telescope view. And we're going to dial this back on the brightness just a little bit. We're going to slew over, which is the fancy astronomy term for move the telescope. And we're going to take a look at Mars. And then we'll only spend a little bit of time on Mars before switching over. And just for fun, we're going to take a look at the moon because it's a first quarter moon tonight. And I tell you, there is no better time of the month to observe the moon than at first quarter. It's far more fun than observing the full moon. If you don't believe me, just hang around for a couple of minutes and you'll see a live view through the scope, and I'll share some images that I've taken earlier this year and kind of try and prove my case to you. So hold on just a moment and let's go find the god of war. Aha, there we go. Now, a couple of you might be wondering in the Instagram the Instagram notice for this and in all the emails that I've been sending out to people, I said that we were going to have 2 telescopes going tonight, and I do have 2 telescopes going tonight. But just like the live stream that I did back in October when we were looking at Mars for the opposition of Mars, one of the telescopes is simply not behaving. So we're using one telescope entirely here so far this evening. It's my old Celestron 8-inch Schmidt-Cassegrain, which is a wonderful telescope. I've had it for 23 years now. And as part of my preparations for this live stream, let me tell you what we did. Well, where'd it go? Of course it disappears now. I cleaned the telescope for the first time since I bought the thing. I cleaned it yesterday. Here we go. Whoop, nope, this is not what I thought it was. This is the animation I promised you guys. This is what was up on Instagram. You can see Jupiter and Saturn getting closer and closer and closer to each other with each passing night. Starting back on December 8th, these were all taken at approximately 6 p.m. here in the Mountain Time Zone. And I'm going to continue trying to take images through, let's say, well, Lord willing, we're going to take images through the end of the year. And this will just kind of be how we wrap up the year, is with this animation. All right. It must be on the desktop. Now I'm going to ask you to please pretend that my desktop is not too messy. You didn't see that. All right, here we go. So if you want to know what it takes to clean a telescope, here we go. Now this telescope wasn't too dirty, but it was time to get some cleaning. And I gave it a good wipe down on the outside, which it desperately needed. And then the real fun came when it was time to clean the optics. And basically use distilled water and cotton balls and do a lot of gentle dabbing. And then eventually, after all of the stuff is just kind of loosened up, you switch over to a little bit of soapy water. But you don't wipe, you only dab, because if you wipe, you're going to kind of drag things across the surface. Here you see I had to actually take out the corrector plate and clean the inside and outside of that, clean that little secondary mirror. The cotton swab just wanted to come apart on the glass, so I had to do this like 3 or 4 times to try and get it all off. But eventually got it all clean and wiped a couple things gently off of the main mirror before putting it all back together. And here you can see that it looks a good bit better afterwards. It's not a night and day difference, but I'm very glad that I did that. Okay, so Mars, that's it. Mars is way high up in the sky right now, but because we are no longer at opposition, Mars is going to be pretty small. Let me see if I can, we're going to change our field of view here just a little bit. Okay. And I'm going to try to zoom in a little bit. Now, this is not changing the zoom through the telescope. This is just enlarging what the camera is picking up from the telescope. We may try and do a little bit of enlarging. Let me see if we can get a better focus on that. Oh, wrong way. Well, a little bit there. Let's try one more. It's really pixelated. However, if you look carefully, you can see a little bit of stuff happening here. Notice how the bottom half of the planet is lighter than the other. That's because that's just a region of the planet where the coloration is lighter. Up at the top, you see it gets light again. That's because Mars has ice caps. Yes, just like we have a polar ice cap on Earth, Mars has one as well. Okay, I lied. It's not just like it, because our ice caps are just water. There are two different types of ices in the caps on Mars. We have a little bit of water ice, but then we have a lot of carbon dioxide, which it's so cold on Mars that during the winter especially, part of the atmosphere freezes out and condenses onto the surface and builds up the ice caps so that they expand from summer to winter to summer to winter, and it can be really, really impressive. I'll try and get some pictures again of Mars here later tonight to share with you guys, but I was able to get some fun images of Mars when it was at opposition earlier this year in October. Some of you may have been able to join me for that live stream as well. So this was the view of Mars. I had a couple of other accessories attached to the telescope to crank up the magnification. And just like you see in our live view here, let's try and do a little comparison. We'll zoom a little bit. Let's play with, oh no, I don't want to do that. Okay. Compare the view of the image that I took back in October with what we see here. All right, there's the ice cap, this tiny little tuft of white right up there at the top, kind of at the tip of where the cursor is right now. If you look carefully, there is a slightly wider section. And then here we've got a lot of discoloration. Well, not discoloration, darker coloration, I'm sorry. You can see that here, and then the lighter area on the bottom. So it's still looking pretty good up there on Mars. And again, Mars is really high up in the sky tonight. And after the live stream is over, go outside, and if you want to, you can find Mars for yourself. It's actually going to be really, really easy. Go up and find the moon, and then just kind of go slightly up and then way off to the left a bit. A little bit less than take your closed fist and extend your arm all the way, and that width of your fist is about 10 degrees. And Mars will be about 2 fist widths to the left of the moon, and it's got a slight red color. You'll be able to see it very obviously and very easily. So I'll get some images after we're done here because it's still so high up, and let's see if anything can compare to what we had this past October. Skies are pretty decent tonight. They're fairly still. Not a lot of turbulence up high, and so maybe we can get some good views. Let me show you just one or two other quick things of Mars. One of the things I was hoping to be able to do for you, ladies and gentlemen, and I think it's going to have to wait for another year, unfortunately, is Mars has 2 moons. They're both very small, and okay, here's a color image that I was able to take of Mars. They're very small because Mars is so bright compared to them. Basically, the moons just get lost in the glare of the planet. However, I have constructed a special filter that I've read about in Sky and Telescope magazine, and what we basically do is it's a filter that only covers half of the camera. And so we can use that to take the glare down on Mars and turn the brightness and the sensitivity up on the camera and try and see 2 of Mars's moons. And they're piddly little things. They're small, they're faint. But to see them through the telescope for yourself would actually be really stinking cool. That coming from a nerd. So take it for what it's worth. Now, you might be wondering, real quick before we move on to the moon, why we aren't seeing any color in the telescopic view. Those of you who've done live streams with me here before may remember that the cameras that I'm using are black and white cameras. Monochrome is the technical term. Mono, just one color. And the reason for that is because black and white cameras are going to be able to give you better resolution than any color camera you're going to get. If you've ever wondered where color comes from on your cameras, it's because you've got different colored pixels, red, green, and blue. And usually what most cameras do is they have one red, two greens, and a blue all in a little square together, and they combine those colors into a single image. So it takes 4 pixels to get a color image and put in some resolution. Whereas with a black and white camera, all of your pixels go into giving you good detail. And then if you use different filters, you can go into Photoshop, you can combine all those. You can still get a color image, but it'll be of vastly better resolution and you'll see more detail than what was possible if you just used a standard color camera on the same telescope. All right, I think we're done with the God of War over there. See you later, Aries. We are going to head over to Luna, which is one of my favorite things. A lot of astronomers that do astrophotography really kind of downplay the moon. They're like, it's just so bright. And it washes everything else out, so they can't see the really faint objects that they're hoping to see. But the moon's just got incredible detail. And I'm going to show you right now, I'm going to show you why the view of the moon here at first quarter is better than what we catch at a full moon. So hold on a second, let me slew the telescope over. Now, because we're using my old C8, we're actually going to be using a long focal length. And the result is we're going to be pretty far zoomed in. And I'd actually love to be a little bit more zoomed out so you could see more detail. But because there's something fun about seeing the moon at a wide view, not just zoomed all the way in. But let's head on over. All right, here we go. Oh, wow, we are so zoomed in. All right, let me zoom back out here. Remember, we'd kind of increased the magnification. Let's get the widest view. Let's see as much of the moon as we can. Boom. And you know what? That's even a little bit out of focus. Let's see if we can do a touch better. Now, believe it or not, the shaking that you're seeing there is because my good old faithful telescope here, I've had it on loan to a good friend out in North Carolina the last couple of years. And believe it or not, tonight's the first time I've used it in, 2.5 years? Yeah, 2.5 years. So apparent, and even before that, I didn't really use the tracking motor on it because I was lazy. But I've gotten much, much better at aligning the telescope so that there are no adjustments right here. I mean, I'm not touching the telescope, and you can see the image is holding stock steady. But if you want to know how fast the Earth is spinning, here, let me show you one thing real quick, and then we'll resume our normal tour. Get this centered just a little bit. Yeah, let's go like that. All right, watch what happens when I turn the tracking motor off. You're about to see the Earth spin. All of that motion is the Earth's rotation. How's that? All right, before we lose the moon. It's dark. I can't find the on switch. Anyways, the tracking motor is a little bit rough because it's just so old and so unloved until recently. So there's all kinds of fun stuff that we're going to see on the moon. And let's continue to play with some of our settings here. I'm going to turn the gain down. I'm going to turn the exposure up. There we go. Yeah. So again, here we're seeing the results of dynamic range. Yet again, the camera can't handle the really bright sections and the really dim sections at the same time. Your eye could, but yeah, take that technology. So we're going to get some of this really bright stuff way off to the edge there. My favorite place to look on the moon is the Terminator, which has nothing to do with Arnold. But the Terminator is the line between light and dark on the face of the moon. And the reason I like it is because that's where you get to see all kinds of shadows. So let's see some of the best examples up here on the left. And don't worry, I'll get that cursor out of the way in a moment. I want to get a little bit better focus. Nope. There we go. Okay, so let's just use this crater right here as an example. So see this dark area right here? That is a shadow being cast by the wall, by the rim of the crater, down onto the crater floor. Just like those of you that live up in the mountains, you know that the sun will be up. You can see the mountain next door or somewhere down the valley is lit up, but you're still sitting in shadow where you live or where you're driving. That's basically what we're seeing here, is we're seeing the shadows of the crater rims. And in some places, what's really fun is you get to see sunrise on the lunar mountains. Look just to the left here. See this one little guy right there above the cursor? That is a mountain inside of the crater floor, and we're not going to get into how craters form and all the different parts of craters. But basically, in the process of impact, some stuff is kind of pushed upward in a mound. So this mountain is catching the sunlight, even when nothing else around it is. Let's go ahead and we're going to scoot around a couple other places along the Terminator and see if we can find some other good examples of that. For those of you who may be wondering, the telescope that I have here is just an old motorized mount. So it's just a simple clock mount. It's programmed to go at 1 speed. I'm not dealing with a computerized set of tracking equipment. I'll get there someday, but for right now, especially tonight, I'm really enjoying the old-fashioned way of doing things. All right, let's continue to work our way along here. Ooh, yeah, there we go. There are the mountains. Let me try and get those centered for you, ladies and gents. So these dark areas on the moon, these are known as mare, or the plural would be Maria. Not to be confused with Mario, for all you old Nintendo video gamers. But here along the edge, these are mountains that were built up over time by larger impacts. There's just some massive impacts that caused these dark areas, and we'll save that for a different live stream some other day. But here you see the tops of the mountains in the light, even while everything down below is dark. Ooh, yeah, check out this guy down here in the lower left. See that? That's just a tall mountain. There we go. It's just a tall mountain in the middle of a flat plain, and it's catching the light while everything down below remains in darkness. Now, the image here is actually not as good as on my other telescope. The telescope that was acting up earlier tonight is an excellent telescope, but I was just having problems with some accessories, honestly. And the other telescope is an Explore Scientific. It's a 5-inch refractor compared to the 8-inch that I have here of a different style. And it has a lower magnification, which is nice because then we can get more of the moon all in the view at the same time here. And the view is a little bit more crisp. And actually, because it's a smaller telescope, it's collecting less light, and we get less overexposure, less blowout of these really bright areas. So actually, we've got about 15 minutes left in the live stream. I'm going to see if perhaps I can get that telescope to behave for you, ladies and gentlemen, real quick. Let's wait just a couple more minutes. Now, all of these things I've been showing you here along the terminator. Let's go back up. These things are not really easy to see when you have a full moon, because in a full moon, the sunlight is beaming straight down on the surface, and so there are no shadows. Now, full moons can be spectacular and beautiful, but again, no shadows. So the section that we were just looking at a moment ago, let's see, the image is flipped. Nope. All right, let's just zoom in. The image that we were looking at, we were basically looking at this area right here. Let me try and flip back and forth between these. Okay, these images are going to be flipped around a bit. See this mare and these two craters down here? We're going to match those landmarks with the image that I just had for you. All right, can anyone see it? Well, we might need to reframe that a little bit. we're looking at this mare right here. We were looking at these mountains right along the center, and there are a couple of your craters. So the view of a full moon is beautiful. There's all kinds of fun stuff to see, views that are just spectacular. All right, before I go and turn on see if we can get the other telescope to behave itself, which it should do with absolutely no problem once I take that other accessory out, and we'll just take a really wide field view of the moon. But let me go ahead and turn down the brightness, and let's look at some of the detail along the edge. There we go. And actually, tell you what, we're gonna take a quick image. See if we can catch 1,000 frames here, and I'll try and process this as well and share this out on Instagram, Lord willing, later tonight at AstroZac, and hopefully this will turn out even better than what it looks like on the screen. All right, while that runs, let me go ahead and switch over to the other telescope. All right, we're almost there. Actually, while I'm thinking about it, let me check back over. Did anyone have any other questions here? Nope, still no one asking questions. Hey, those of you that are still out here, please feel free to ask a question in the live stream, and I will do my best to answer it. All right, I'll be back in about 2 minutes or so. I'm just changing out some accessories on the other telescope, and then we will take a different look at the moon to close out our evening. And hey, look at that, 2 minutes. Not too far off of schedule. I'm going to move things around here a little bit so I can adjust the other telescope a touch, but let's switch over to the other camera. Ooh, there we go. All right, let's watch this come into focus. All right, there you see it. Oh, you're kidding me. I'm not using a diagonal, and so all of my focusing is just a bit off. All right, real quick. Let's see if this does it. Well, we've been doing well, but we might end up having to finish the night on a low note. This just does not look like it wants to focus. Yeah. Accessories, they only act up when you really are under pressure. Okay, well, that's it for the night here, ladies and gents. I don't think we're going to do any better than what we had on the moon. If you want to hang around for the last 5 minutes, I'd be honored by that, and we will. I'll continue to fuss here, and I know which accessory has always worked, and I'll just trade out and go back to my normal configuration, so we can take one last look at the moon through the Explorer Scientific. But thank you, ladies and gents, for tuning in tonight and enjoying the live stream of Jupiter and Saturn. As many images as I can from this evening on my Instagram feed, so follow me at AstroZac, and I'll be sharing some of those this evening and maybe some of those tomorrow. But is my mom's 70th birthday. Happy birthday, Mom. And I'll be headed down to celebrate with her since I've been in isolation for 2 weeks up here. I should be pretty safe on my side. But thank you again for joining me, ladies and gents. If you want to hang around for another 5 minutes, I'll have that other accessory and we'll take one last alternative look at the moon. Otherwise, please follow me on Instagram. Please subscribe to the YouTube channel here. I'll be doing some more live streams in the new year. In either late January or early February, I'll be doing a live stream dedicated to just the moon, and we'll be having some fun looking at that. And then a little bit later in the year, I'll be doing some live stream with some solar viewing. Now that we are out of the bottom of the sunspot cycle, there's a lot of activity up on the sun these days. There was actually a flare earlier today. I saw it while I was watching the feed from the National Solar Observatory's telescopes. What was a nice black sunspot in regular white light showed a very different structure when viewed through a different wavelength. So I'll be doing a bunch of fun and fancy solar viewing as well. If you're interested in any of those as live stream events, I'll also be doing a lot more videos for my astronomy classes, and if you subscribe, you'll have access to those here. So thank you again, ladies and gents. Feel free to hang around for one last look at the moon through the Explorer Scientific. Otherwise, have a great night, stay safe, and Merry Christmas. All right, for those of you that are still here, I've switched out the accessories, and of course now the problem is I've got a tree in the way. So I'm going to move the telescope, and that'll shoot the tracking alignment, but that's okay because we're more or less done for the night. Let me shift this telescope and we'll take one last view. how's that for a look at the Terminator? Alright, let's turn this brightness down and let's get a good view and get some good focus here. Ooh. Oh yeah, that's beautiful. Okay, ladies and gents, so here we have no additional magnification. This is just the telescope view. And I'm going to try and find the right balance. When you're taking images through a telescope, it's actually fairly forgiving. So what you can do is you actually want to take an image that's just a little bit too dim, because when you do all of your image processing later on, you can fix that. However, if you overexpose your image, you're done. There's a very limited ability to fix those kinds of things. So this is looking quite good. And what's amusing is now that I've randomly shifted the telescope, it seems to be tracking better than what I had set up earlier. Alright, I'm going to take the brightness down just a little bit more because you see we've got some really white stuff in the bottom left there. And let's see if we can rotate the camera just to get a better angle at that. There we go. Now we've got the whole moon in there. It's a beautiful night tonight. Look around the edge of the moon. So we had a lot of turbulence for Jupiter and Saturn earlier because they were so low down on the horizon, but now that we're looking way up in the sky, I mean the moon's way up there. Oh, there is no turbulence at all up there. So let's let's see what happens. We're going to take, whoa, well I don't think we'll get 2,000 frames if it's only going at 15 frames per second, but we'll take a bunch of frames and I'll share this out on Instagram as well. And this will probably be my last thing for the night because I've got to get in there, and tomorrow's my mom's 70th, but today is also one of my nephew's birthdays, so I got to give him a birthday call there. So again, thank you ladies and gentlemen for sharing your evening with me. Hope this was worth it. I know I've had some fun, and we've overcome a couple of minor technical difficulties. I'll be sharing everything out on Instagram. Please subscribe to the YouTube channel at Astrozac for more live streams and other astronomy videos coming up in the new year. Again, Merry Christmas and stay safe, everyone. Good night.